In the third question, we have x square e power x. Okay, there's exponential function and an algebraic function. So we know that this is easy to integrate. This will be v, and this will be u. Right or not? Yes. Okay. So I, which is equal to integral of x square e power x dx, will be equal to what? X square will be taken as constant. Integral of e power x dx minus integral of derivative of x square is what we are interested in. Integral of e power dx, e power x dx, and complete integral of this whole expression, right? That's the formula. So first function integral of second function minus derivative of first function into integral of second function. Take a hard integral of this second term. X square is okay, e power x, the integral is e power x, minus derivative of x square is 2x, integral of e power x is e power x dx. This is what you have. Oh, x square has reduced to x now, but here also we have two different types of functions, and integration again will involve by parts, another step of by parts. This x square e power x is okay, minus this 2 can be taken out, and the integral of x into e power x will follow that same trend. This is the first function times integral of second function minus derivative of first function, integral of second function, and Maha integral of this. Yes, this is what you get. So this is x square times e power x minus, this is 2, and in the bracket you have x times e power x. Is that okay? Yes. Minus integral of this is 1, integral of e power x is again e power x dx. This integral is e power x, right? So 1 into e power x is e power x, so this bracket becomes this e power x. Is that okay? Yes. X square times e power x minus 2x e power x and minus of minus plus 2 is what I get. Integral of this is e power x plus a constant of integration will be added at the end. And this is my final answer for this question, or I can write it as e power x, if you can observe, can be taken out common. X square minus 2x plus 2 is what I get, plus a constant, and that is my final answer for this particular question. Is that okay? Yes, this is what you get. What else? Is there any other approach of handling this? Yes, there is one very unique approach for handling this kind of question related to e power x and algebraic integral, right? So if you have algebraic function, algebraic or basically a polynomial, not algebraic, or basically a polynomial can be handled easily. How do you do that? So there's one important result, right, which is given once again in the NCERT, and we'll see some questions based on that as well. But that approach is e power x fx plus f prime x dx. This integral is equal to what? This integral is e power x times f of x plus constant, right? This is very interesting. This can be derivative e power x into fx plus e power x into f prime x. This is what you'll get. Once you differentiate e power x, that is e power x times fx, then you differentiate fx, which is f prime x. So e power x fx, e power x f prime x is what you get as the integral derivative. So integral of this expression will be this. That's what you can observe, right? And this particular result can be derived directly with the help of by parts. These are all rules of by parts. But what's the use of this over here? Okay, in case you have a polynomial, e power x with a polynomial x square. So a derivative of a polynomial will also be a polynomial, right? Yes. So we try to, instead of this x square, we try to create something of this sort, fx plus f prime x over here. And how do we do that? We add or subtract certain things. We add or subtract certain things. If this is fx, then f prime x will have 2x, right? So we'll add a 2x. The derivative will have extra 2x, right? Oh, but there's no 2x over here. Yes. And to take care of this added 2x, we'll have to subtract 2x. That's the first step, right? But then this becomes a part of fx, so its derivative should be present over here. Yes. Derivative, that is f prime x. We are looking to create f prime x over here. For this term, for this particular term, you can see that derivative is 2x. But to take care of this extra 2x, we added something over there, and therefore we need to subtract that certain thing minus 2x. So now fx, we go a step further and since we are getting this new term as fx, we'll have to create the derivative. Once again, take a look at the derivative. X square, the derivative is 2x, yes, and minus 2x, the derivative is minus 2. So this should be the derivative, yes. But then what happened to this minus 2? Where does this minus 2 come from? Can we subtract minus 2 just like that? No, we'll have to add minus 2, right? This is what you get. So you started with x square e power x, yes, and you wrote it as x square minus 2x minus 2 plus 2x. This is plus 2, right? Mind out. X square minus 2x plus 2 plus 2x minus 2. And why did you do that? Because you wanted to create, along with fx, f prime x. In case of polynomial, this can be handled easily. And the derivative of this whole expression now, the derivative of this whole expression, do you observe that this is this? Oh, how do you do that? X square derivative is 2x minus 2x, the derivative is this, 2 is the derivative is 0, right? And if this is fx, this is f prime x, the integral of this whole expression with respect to x will be equal to e power x times fx. Is this what we have been doing? Yes. Is that what we got over there? Please check that answer. E power x times x square minus 2x plus 2. Yes. This is pretty simple, sir. A very short approach, but may not be so simple for some of you. With practice, with ample practice, you'll get this completely, right? And let's take a look at this complete thing once again. Over here, what did we do? We started with e power x times x square. Let's take a look at it again. We wanted to create in the bracket, along with e power x, we wanted to create two particular functions. This is, if this is fx, this should be f prime x, right? That's our goal. So we have only x square over here. So that has to be a part of fx. First of all, why? Because if that becomes a part of f prime x, will only increase the powers, right? Will never decrease the powers of x over here. So x square, and its derivative, which will be simply 2x, comes over here. Okay, this whole expression should have been equal to x square. So this extra 2x which has been added should be subtracted from somewhere, and you cannot subtract it over here only. These are two separate terms. You have to subtract from here only, right? So now x square minus 2x plus 2x is equal to x square. That's also okay. But do we have the derivative of this over here? No. X square minus 2x, the derivative is 2x minus 2. But then is this equal to this? No. We'll have to add a 2 over here. So you go back and forth, back and forth, back and forth a few times, and you reach this stage. Now the derivative is this, and this whole is equal to this. Yes. So x square has been written as this, where fx and f prime x can be clearly seen. And the integral will be e power x times fx, right? That's what you get. Oh, but we have solved using this long approach. This is useful, right? In the board examination, for the NCERT people, you'll solve using this approach. But in the competitive exams, this is what you'll be using. Yes, that's the final solution for this particular question over here.